Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
So this would be the third installation about the same problems, that body thrown horizontally and there is some dot and this dot belongs to this line, so it's not necessarily an incline. If there is a swimmer who jumps, he doesn't jump on incline, he jumps in the water and water is here, but the distance between H and L such that they lie on this line, invisible line that goes under angle alpha, or it may be really an incline. And so we had two solutions, one with this system coordinate, another with this, and now they ask us what happens if this is really an incline and this body is a ball and it's like elastic collision, so no energy is lost, and what happens? And the answer is this. When there is a body, it travels this V0, and then it goes down, and it hit with some speed. And it's reflected with the same exact speed, and it goes again, and again. And the question is, what is the time between those? We found the first time, we found this time. This is the formula that I derived last time, but this is very simple formula. We arrived with this solution very easily. It has very nice physical meaning, because along this y-axis we have v final on the top of this motion. It's 0, so we can write 0 equal initial speed along y-axis, and this is v0 sine alpha plus at, but a is minus, so it's minus, and this is g cosine alpha. In this system coordinate, g is this, it's negative, and this g cosine alpha like on this picture. So one way or another, and we immediately have time, equal v0 sine alpha divided over g cosine alpha, and we multiply by 2 because we go up in this direction and we go down, and it takes twice as much time. So, and that was our way of thinking. And tell me what changes now between this collision and this collision and this collision. And the answer, of course, nothing. It's exactly like basketball bounces back from the floor and goes up with the same speed like it goes down. So in this direction only, it goes up and down velocity. It changes. When we're approaching, it's directed this way. When we're bouncing up, it's directed up again. So it's exactly the same situation like in the beginning. It's exactly the same Vy equal V0 sine alpha. It's the same speed all over in every reflection, in every bounce. It's the same speed that goes in this direction. And in this direction nothing changes. G is this way, projection is this way, projection Gy, and this is G, and this is Gy, equals exactly G cosine alpha, because alpha is this angle, and this would be G cosine alpha, and this would be minus because it's directed this way. And so everything would be exactly the same. All things that I wrote here and wiped out for the first parabola would be valid for this parabola and this parabola. So essentially it would be very similar parabolas, shifted and moved. Things will change though in this direction, because in this direction now it's acceleration. So during the same time t, from that point and to that point and to that point, body will be accelerating, because g sine alpha will be accelerating it down this axis. and so it will be moving with much faster speed. And so this would be smaller than this, and this would be longer, and this will go even further. And I hope this emphasizes how simple solution began if we choose this right system of coordinate. Because in this system of coordinate, it would be much more difficult for us to calculate time, because between this collision and this bounce, between this bounce and this bounce. And this shows that choosing the right system of coordinate may be very helpful. If you like this fact, like. If you want more, subscribe. If you want to be notified, bell. If you have question or problem, write it down. Thank you.